A semi-analytic solution of the Caputo-Fabrizio fractional order mathematical model for cancer treatment by stem cells and chemotherapy. Abstract: in this paper we develop an algorithm for the semi-analytic solution of the Caputo-Fabrizio fractional order mathematical model for cancer treatment by stem cell and chemotherapy using Laplace Adomian decomposition method. The recursive iterative schemes for the model were solved using the model parameters and the given initial conditions. The result obtained is in good agreement with the one presented by Alqudah, 2020, validating LADMs efficiency and accuracy in finding the approximate analytic solution of the Caputo-Fabrizio fractional order mathematical model for cancer treatment by stem cell and chemotherapy. Keywords: cancer disease, stem cells, effector cells, tumor cell, chemotherapy, Caputo-Fabrizio. 1.0 Introduction. Cancer is a disease which is non-communicable but lethal. It constitutes 12% of all deaths globally, where new cases and death from the disease keep rising. 1. According to 2, cancer is responsible for 72,000 deaths in Nigeria every year, with an estimated 102,000 new cases of cancer annually. 3. Added that about 116,000 new cases were recorded in only 2018 and about 41,000 died of cancer related in Nigeria. They also added that if proper care is not taken against cancer risk factors, the cancer burden in Africa is projected to double from 1,055,172 new cancer cases in 2018 to 2,123,245 by 2040. The overall age-standardized cancer incidence rate is almost 25% higher in men than in women, with rates of 205 and 165 per 100,000, respectively. Male incidence rates vary almost fivefold across the different regions of the world, with rates ranging from 79 per 100,000 in Western Africa to 365 per 100,000 in Australia/New Zealand. NNCCP 2018-2022. There are more than 200 different kind of cancer that exist worldwide, but the common among them include breast and cervical cancer, which are common cancer in the world and the most frequent cancer among women, prostate cancer and liver cancer common in men, colorectal cancer, which is common cancer in men and in women worldwide. 4. Some of the common signs and symptoms of cancer may include pyrexia, ache, tiredness, changes in skin appearance, redness, sores that won't heal, jaundice, darkening, unplanned weight loss or weight gain, lumps or tumors, mass, inconvenient swallowing, changes and difficulties with bowel or bladder function, never-ceasing cough or throatiness, curdling of breath, chest pains, bleeding and discharges that can't be explained. 5, 6, and 7. Cell mutations and other factors that assist in damaging the DNA eventually led to cancer, and these factors include air pollution, smoking, heavy alcohol drinking, eating a poor diet, obesity, exposure to chemicals, and other toxins. 8. And if these triggering factors are prevented, it will go a long way in minimizing the risk of affecting with cancer. 9. Different clinical procedures are used in the treatment and management of cancer, include radiotherapy, chemotherapy, surgery, and immunotherapy, which depend upon the patient's condition, location of the tumor, and the stage of cancer. 10. It has been for many years back biological processes are being modeled mathematically to provide means of a better understanding of the processes. 11, 12, 13, 14, 13, 15, 16, 17, 18, 16, and 19 have developed several linear, nonlinear and stochastics classical mathematical models that provided a comprehensive understanding of hematopoietic stem cell dynamic, the coexistence between the healthy and mutated cells, the rapid and uncontrolled proliferation of immature cells that invade the circulating blood, which result to cancer disease. In understanding more on the dynamics of cancer illness, and in particular to find theoretical conditions for efficient delivery of drugs under various treatments such as chemotherapy, immune therapy, radiotherapy, and to choose suitable dosages, durations and frequencies, so many works have been carried out, which include 20, 21, 20, 22, 23, and 24. A new classical mathematical model of cancer treatment by stem cells and chemotherapy was developed. 25, which modify the patient immune system and subsequently provide hope of a cure for the patient. Thus, the existing model. Many areas of nowadays researches such as physics, engineering, biological sciences, finance, economics, and other related areas have been observed to make a shift from classical-based models that were based on integer-order derivatives to fractional-order derivatives. Because fractional derivatives can provide a better agreement between measured and simulated data than the classical derivatives, the fractional derivatives have a special characteristics of memory effect that depends not only upon its current state but also upon all of its historical states, which does not apply to classical derivatives 26, 27, and 28. These additional properties increase the accuracy and reliability of fractional order systems than the ordinary or classical order systems, as testified by the works of 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37. 2.0 Fractional differential equations. Fractional calculus is one of the branches of mathematics that investigate the properties of integrals and derivatives of non-integer orders, which involves the notion and methods of solving the differential equations that involves fractional derivatives of the unknown function. There are three important definitions of fractional differential equations. They are the Riemann-Liouville, the Grunwald-Letnikov, and the Caputo definitions. 3.0 Adomian decomposition method. Among the several semi-analytic methods for the analytical approximation of both linear and nonlinear problem is Adomian decomposition method, ADM. A great mathematician, George Adomian from America, developed the method to serve as a semi-analytical method for solving numerous mathematical problems of partial and ordinary differential equation in linear and nonlinear system 38. Now with extension to fractional order derivatives 39. ADM provides efficient algorithm for the approximate analytical solutions 38. ADM warrants the solution to both nonlinear initial value problems and boundary value problems without unphysical restrictive assumptions such as required by linearization, perturbation, ad hoc assumptions, guessing the initial terms or a set of basic functions and so forth. 40, 39, 41. Hence ADM solves nonlinear operator equation for analytic nonlinearity by providing an easily computable, rapidly verifiable, and rapidly convergent sequence of analytic approximate functions 42. Many analytical approximations have been carried out using ADM to provide an approximate semi-analytic solution of real-life problems, among which are application of Adomian decomposition method on mathematical model of malaria 41. Solution of typhoid fever model by Adomian decomposition method 43. 3.1 Adomian decomposition method in solving system modes. A system of ordinary differential equations of the first order as defined by 42, can be considered as 3, NNNNYYXFYYYXFYYYXFY, 112 to 11 1 == where each equation represents the first derivative of one of the unknown functions as a mapping depending on the independent variable, and unknown functions. X. 4.0 Caputo-Fabrizio fractional derivative by Laplace Adomian decomposition method. Fractional order mathematical models are also solved using the Laplace Adomian decomposition techniques. This has been proved efficient through researches as 43 who carried out numerical solution of integral differential equations of fractional order by Laplace decomposition method. 39. On modeling of epidemic childhood diseases with Caputo-Fabrizio derivative by using the Laplace Adomian decomposition method. 4.0 Results. In order to validate our semi-analytic solution of the Caputo-Fabrizio fractional order mathematical model by the derived recursive iterative scheme through Laplace Adomian decomposition method, we consider the value of Q equals 1 corresponding to the classical model of Alqudah, 2020, which is shown in Figure 1a. Where the present result presented in Figure 1b is in good agreement with the result presented by Alqudah, 2020. Fig 1a. Numerical solution of the classical by Alqudah, 2020, Fig 1b, semi-analytic solution by the LADM. We now give the numerical simulation of the individual compartment with varying values of the fractional order. The result is presented below. 5.0 Conclusion. In this paper we develop a recursive iterative formula for the solution of Caputo-Fabrizio fractional order mathematical model for cancer treatment by stem cell and chemotherapy. The result obtained by this method is in good agreement with classical solution of Alqudah, 2020, as shown in Figure 1a and 1b. Furthermore, numerical simulations were carried out at different value of Q for each of the individual cells were presented in both tables and figures.